114 people died on a dance floor. Not because of a bomb, not because of a fire, because someone changed a design detail, and nobody checked the math. It was July 17, 1981. Inside the Hyatt Regency Hotel in Kansas City, about 1,600 people had gathered in the atrium lobby for a tea dance. The music was playing. The floor was crowded. Above the dancers, suspended walkways connected the second and fourth floors of the hotel, glass and steel platforms that overlooked the lobby below. At 7:05 in the evening, one of those walkways fell. The fourth floor walkway dropped onto the second floor walkway directly beneath it. Both platforms, each weighing 32 tons, crashed onto the crowded dance floor below. The rescue operation lasted 14 hours. Workers used hydraulic jacks, acetylene torches, and cranes to move debris. Some victims had to be reached by removing sections of the concrete around them. When it was over, 114 people were dead and 216 were injured. It was the deadliest structural collapse in United States history. And it happened because of a phone call. To understand what went wrong, you need to understand how the walkways were supposed to work. The Hyatt Regency Kansas City opened in July 1980, a 40-story hotel built around a dramatic multi-story atrium. The atrium's defining feature was 3 suspended walkways that crossed the open space at the second, third, and fourth floor levels, connecting opposite wings of the hotel. The second and fourth floor walkways were stacked directly above each other. They were suspended from the ceiling by long steel hanger rods that ran from the roof structure all the way down through both levels. In the original design, those rods were continuous. One long rod running from the ceiling, passing through the fourth floor walkway, and continuing down to the second floor walkway. Each walkway was secured to the rod by nuts and washers. The load of both walkways was distributed along the full length of each rod. It was a sound design. Not overbuilt, but adequate, if built as designed. It was not built as designed. During construction, and the steel fabricator, a company called Haven Steel, ran into a problem. Threading a single continuous rod through 2 floors of a building is difficult. The rod has to be threaded along its entire length, which is expensive and time-consuming. Havens called the engineering firm and proposed a change. Instead of one continuous rod, use 2 separate rods. The upper rod would run from the ceiling to the fourth floor walkway. The lower rod would run from the fourth floor walkway down to the second floor walkway. On paper, it seemed like a reasonable simplification. The walkways would still be supported. The rods would still be there. What nobody calculated, or at least nobody caught, was what this change did to the load. In the original design, and the connection at the fourth floor walkway only had to carry the weight of the fourth floor walkway itself. The second floor walkway's weight was carried separately by the lower portion of the continuous rod running straight to the ceiling. In the new design, the connection at the fourth floor walkway had to carry something different. It now had to carry the weight of the fourth floor walkway, and the weight of the second floor walkway hanging below it, transmitted through the lower rod up to that same connection point. The change doubled the load on the fourth floor connections. The original design was already marginal. The National Bureau of Standards investigation later found that the walkways had only minimal capacity to resist their own weight. Here, the lead investigator concluded they would have eventually failed under just 1/3 of the load they were carrying that night. The design change made an already inadequate connection carry twice what it was supposed to. The modified shop drawings were submitted to the engineering firm, GCE International, for approval. An engineer reviewed them. He stamped them. The construction proceeded. Later investigators could not find any evidence that anyone at GCE had recalculated the loads at the connection points after the change was made. There were no calculations, no safety factors checked, no documentation that anyone had looked at what the design change actually meant for the structure. It has been observed repeatedly by engineering professors and textbooks ever since that a first-year engineering student could have spotted the problem. The math is not complicated. If you change where the second walkway hangs, you change what the upper connection carries. That is it. Dozens of qualified engineers reviewed the modified design. None of them caught it. There had been a warning. In October 1979, before the hotel even opened, a large section of the atrium roof collapsed during construction when a connection failed. 2,700 square feet of roof came down. Nobody was killed. Construction continued. The hotel opened in July 1980 and was immediately celebrated as one of Kansas City's architectural achievements. The atrium was spectacular. The walkways were a feature. 1 year later, they fell. The rescue operation on the night of July 17th was one of the largest in Kansas City history. 5 hospitals mobilized trauma teams. Local companies volunteered equipment. Rescuers worked through the night under a 60-ton pile of steel, concrete, and glass. Victims who could not be reached immediately were given morphine. Some required surgical procedures at the scene. The last survivor was pulled from the debris 14 hours after the collapse. The investigation that followed was exhaustive. Within days of the collapse, the Kansas City Star had already identified the design change as the likely cause. The National Bureau of Standards confirmed it months later in a detailed technical report. The engineering firm GCE International was found guilty of gross negligence, misconduct, and unprofessional conduct. The engineers who had stamped the modified drawings lost their licenses in 4 states. The firm lost its national affiliation. No one was convicted of criminal negligence. Every defendant denied legal liability. The hotel paid over $140 million in settlements. The lead investigator from the National Bureau of Standards, Edward Frang, characterized the entire project as a culture of everyone wanting to walk away from responsibility. The Hyatt Regency disaster became one of the most studied cases in engineering ethics history, and it is taught in universities around the world as the defining example of what happens when a design change is approved without recalculating its consequences. The lesson sounds simple. When you change a design, you check the new design. You recalculate the loads. You do not assume that a modification is safe just because it looks similar to the original. But the real lesson is harder. Dozens of qualified people looked at those drawings. Engineers, contractors, inspectors. The modification was reviewed and stamped and approved. The hotel was inspected before it opened. Nobody saw the problem. Not because they were incompetent, but because the problem only becomes visible if you stop to ask a specific question. What is this connection now carrying that it wasn't carrying before? Nobody asked. In the original design, the connection was adequate. In the modified design, it was carrying twice the load. Those two facts were never placed next to each other by anyone before the night of July 17, 1981. One phone call changed the design. One stamp approved it. One calculation that was never done left that connection holding twice what it could bear. And 114 people died on a dance floor. If you found this story worth knowing, there are hundreds more like it. Moments when a small change, made for convenience, approved without question, became the thing that everything else failed around. That is what this channel is about. Next video, on June 3, 1980, A U.S. Air Force computer system detected what appeared to be a massive Soviet nuclear missile attack. 200 intercontinental ballistic missiles, headed for the United States. The alert went all the way to the top of the military command. B-52 bombers prepared for takeoff. The cause? A faulty 46-cent computer chip. Subscribe so you don't miss it.